Hello and welcome to the chapter 19 of our comprehensive course on AI, ML and DS. And in chapter 19, currently we are doing the hypothesis test. In previous lecture, we have talked about single or one sample t-test. Now we are talking about two sample t-tests. So let us start our 23rd lecture of 19th chapter with that two sample t-test discussion, right? Two sample t-test is used to compare the means or proportion of two independent groups. So that is the real most important difference between one sample and two sample. In one sample, as the name indicates, there is only one sample whose sample mean of one particular quantity you find and compare it with some known given number. For example, we did in previous lecture that you have a supplier and he claims that each of my carton is of weight 500 gram. So you check using one sample t-test that if I take 30 samples at random, then are they actually having 500 gram weight, or maybe there is a significant difference between the supplier's claim of 500 gram, which is called population mean, and the sample mean, that is 30 samples which you have taken from the supplier, and find their mean weight. Then the question is, are they same or different? So we use hypothesis testing to check that. But there is no comparison between two different samples, right? Just one sample, of course, one sample means 30 samples, but one experiment, and you find the mean weight of those 30 samples, and you compare with a given fixed value, that is the supplier's claim of 500 gram weight. Now here it is a different thing. There are two different samples, two independent samples, and you want to compare. For example, four examples I have given. One is this, comparing average exam score between students who use the new study app and those who did not use the new study app. So suppose yours is a progressive school, and as the principal of your school, you want to introduce some digital learning application which is developed by a developer for your school only. Now you want to check before adopting it all over the entire population of your school's students that is the app really helpful. So first you will do a mini experiment in which you will isolate two groups, one group of say 50 students and another group of say 50 students, and one group will use the study app and another group will not use the study app, and then you will compare their average exam score. So here what will be the null hypothesis? Null hypothesis is always status quo. Whatever intervention you are doing, that has no effect. So no effect or status quo. So here null hypothesis will be that the mean score of both groups, that is one which is using the study app and another which is not using the study app, both groups are equal only. That means the use of study app has no significant effect. But alternative hypothesis is that says that the mean score for the students who use the study app is significantly higher. Okay, so now you want to check this. Then for that you can use two sample t-test, right? Similarly, another is this example. That is the example in business, that testing if sales in two regions A and B are significantly different after a marketing campaign. So that means suppose your company has operations in multiple regions, and you want to assign a big marketing contract to a marketing company, but you don't want to spend so much of money without some statistical proof. So what you do is you tell the company that my sales are in say 26 or 30 sales states of entire India. You just choose two states, and in one state you don't run marketing campaign, and in another state you run the marketing campaign, and then show me the results. So here also null hypothesis means whatever intervention you are doing, running a marketing campaign, has no effect. Or in other words, the sales in region A and sales in region B, which remains the same. But second alternative hypothesis says that sales in A, in which you ran the marketing campaign, is not equal to, say it is greater than sales in B, in which you did not run the marketing campaign, right? So that means that here I ran my marketing campaign and the sales here is significantly more. So that is my alternative hypothesis. In that case, again I can use a two sample t-test and I can decide whether my null hypothesis is true or alternative hypothesis is true. And if alternative is true, then in that case I will assign the job to the marketing company for all other states also, right? So you don't spend money haphazardly. You have to do proper this kind of what you call due diligence. Then an online education platform wants to test if students who complete assignment score better than those students who do not complete assignment. So again, there are two different groups. One group is those students who complete the assignments, and another is those students who do not complete the assignments. So again, the completing of the assignment is a kind of intervention, some event, and you want to say whether it affects the outcome or not. Outcome is score, right? So null hypothesis is always status quo, no change of intervention, or that means that the score of assignment completers and the score of assignment non-completers, that remains the same. But alternative hypothesis is that score of assignment completers, average score of course, That is, you again make 50 assignment completers and 50 assignment non-completers, and then find the average score for both groups is significantly higher for assignment completers than not than for non-assignment completers, right? So that is called the alternative hypothesis. Now again, if alternative hypothesis comes to be true, then in that case, next batch students will, or from these students only, but from next chapter, they will be presented with this result and they will be forced or motivated to complete the assignments, saying that those who complete the assignment get better score, right? Similarly, this is one more thing. Example D. Okay, this is not C but D. So it says that there is an online retail platform and it wants to test if there is significant increase in the click-through rate by using some new user interface. So taking a new user interface, that is the new intervention which you are doing in your data, but null hypothesis says that it does not affect anything. So it does not affect outcome. Outcome is here in click-through rate. So null hypothesis says click-through rate remains same for both old user interface and new user interface. Alternative hypothesis says click-through rate does not remain same, or rather I would say that click-through rate increases for the new user interface compared to the old user interface. So again, any online platform does not assign the job of to UI designer directly, because UI UX experience designer are also costly. Their salary is high. Okay, so they first tell that, okay, give me one sample design and I will run a small experiment in which a small sample of my existing customers will be presented with new UI and another small sample will be presented with old UI, and then I will check if my click-through rate has significantly increased. So if alternative hypothesis is correct, then I will assign the contract to the new UI, because if everything is going to remain same only, then why would I spend money on that UI designer, right? Okay, so this type of business problem can be solved using two sample t-tests. We are taking exactly this example only, this click-through rate example only, for explaining the same two sample t-test using a code. Okay, so this is importing the libraries. All are usual except this one. From scipy.stats, import t-test underscore ind, independent sample t-test. That is, two independent samples are taken, and we want to conduct a t-test from which we will ultimately find p-value, and we will check if p-value is less than that significance level 0.05, then we will say that reject the null hypothesis, or if p-value is greater than that 0.05, so then in that case we will not reject the null hypothesis, because p-value is the probability of falling under null hypothesis, or you can say it is the probability of having your outcome under null hypothesis, right? So null hypothesis says that by changing the user interface, there is no change in the click-through rate. So if the probability comes out to be greater than 5%, then you will say that that means there is not significant change in the click-through rate for your sample, right? So then again, this is just seed to produce a reproducible result, and let us create group A and group B. In group A, you can write np.random.binomial, and you can put some values here. N is equal to 1, P equals 0.52, and size equals 500. Okay, and that is the parameters which you have to supply for your binomial distribution. This is cutoff the CTR, or that is click-through rate of 52%. You want to generate a sample with which is having binomial distribution and having probability 52%, or that means out of 100 clicks, the 52% of the clicks are leading to some positive outcome like conversion or something. That is, the buyer actually buys something, right? And similarly here, this is also a click-through rate distribution. Again, it is a binomial distribution, and you are creating the 48% probability. Size, that is the number of observation in both, they are 500 only. Now actually here I am simulating the data, but when you are working as a data scientist, then these two data will be given to you from the actual customers' behavior when they log into the online retail platform, and then they actually do the clicking and browsing and etc. So their entire customer journey or their browser history is tracked, and using that, this kind of data will be given to you, that for group A you will find that click-through rate is 52%, and for group B the click-through rate is 48%, right? Then you will find the mean for those two, and then you will perform a two sample t-test. But before I do that, first let me only still take this that much in a new cell, and first let me print each group, so that you will get an idea about what kind of data is obtained from whether by actual experiment or by simulated experiment, but what kind of data is obtained, that you should get idea, and what is the value of mean A and what is the value of mean B, right? So this is what I want to print. Okay. Now, if I see that and let us print it. So you can see this is my first data set. One means the person has clicked and zero means person has not clicked. So that is the meaning of binomial distribution. That is just like that coin toss, head means one and tail means zero. That kind of two outcomes are there. So you want to test your design that on the each page or on each element of your page, whatever you have chosen as your study target, whether the person clicks or not. So this is the sample in which in 52 out of 100 places the person has clicked, while this is the sample in which in 48 out of 100 places the person has clicked. And this is the mean of A, that is 0.508, the mean click. And similarly, this is the mean click of is for B, group B, and that is 0.458, right? Okay. Now perform a two sample t test. So again, every t test normally gives two outcomes. So it is always better to read it from right to left. So t test underscore IND, independent sample or two sample, in which as an argument what you will provide your group A and group B. So that means this entire sample of 300, I think, yeah, 500 click data, and similarly this entire sample of another 500 click data. Say one was click data for the old user interface and another is the click data for the new user interface, like that. Okay. And if you do that, supply these two entire data sets for 500 click data, 0 means not clicked and 1 means clicked, and then perform t test underscore IND, then it will give two results, t statistic and p value, and you are storing those two results on the these two variables on the left side, and then you are printing those two results. Okay, so let us print, and if my p value comes out to be less than the significance level of 5%, then I will say that the null hypothesis is rejected, or that means the click-through rate are significantly different, or the introduction of new user interface has changed the click-through rate. But however, if p value comes out to be greater than 0.05, then I will say that null hypothesis is, we fail to reject null hypothesis, or in other words, that means null hypothesis is correct, and null hypothesis says that click-through rate remains same for old user interface and new user interface. So that means no significant difference in the click-through rate. So let us print that much now. So mean CTR for the group A was 0.51. and mean CTR for the group B was 0.46. They are these only, just rounded. Okay, so they are these only. So that you found t statistic. Now t statistic came out to be less. Now less is always a relative thing, but if you remember the previous example in the last lecture, then the t statistic was -7 point something. Minus or plus is not important, but the magnitude is important. So that was large, and whenever t statistic is large, then the chances of p falling below this is also high. But whenever t statistic is small, then t will usually not fall below the significance level. However, this small and large of t statistic, that is only subjective thing, and that is why conclusive decision is never made using t statistic, but finding corresponding value of p value of from that t statistic, right? So if you do that, then you find that p value is 0.1139. Now that value is far greater, right? So that means that I will have to say my null hypothesis is valid, that there is no significant difference between, that is this hypothesis, because this p is greater than 0.05. This is the p value which is greater than. So this else part will be executed, and therefore no significant difference between the click-through rate. So if this kind of result is obtained, then you will ask the UI designer that, dear, you are asking me to give the contract for my entire retail portal, but unfortunately for small samples, two small samples, I got this kind of result. So there is absolutely not much difference. Significant difference is not obtained by new design. So then why should I pay you? So instead of that, you make another design. So he will bring a better design, and suppose next time you get p value of 0.001. So in that case, you will say that yes, now 0.001 is less than this significance level, and then in that case, this part will be executed. So yeah, then you will say yes, now the click-through rate is statistically significant. So now I can assign you the contract, right? So I am trying to make this as interesting as possible, because otherwise statistics will look very dry. But if you take it that way, that actual business case, and as if you are conversing with the business stakeholders, then it looks very nice. Okay, now I will remove this for next run whenever I take the next class, or let me keep it because it was informative. Okay, fine. I just remove the output. So clear cell output of all cells. Fine. Now we found, or here this at least that here there was no significant difference. Can I check that visually? So yes, we can check it visually, and we can plot mean click-through rate for the two groups, and you can see that there is not much significant difference. This is actually these values only, just shown by a bar chart, that for first group it is 0.51 and for another group it is 0.46. Now for one sample only the difference is so large, because when you take a diverse sample, then there should be a much more pronounced difference between the click-through rate. much more pronounced is how much, that you will never decide visually. Remember that this much is much more pronounced, or maybe this much is much more pronounced. No, you will always decide by p value. Okay, but here at least p value is like this, and visually also it confirms that there is not much difference. Now histogram you can plot for the two click-through rate distribution, and again you can see that there is not much difference. Here in this, 0 stands for no click and 1 stands for click in both, right? And group A is shown by this and group B is shown by this, right? So in that case, this is these are the two groups. Click-through rate distribution again is more or less similar. Okay, so fine, there is not much difference. While in plot, you can plot for the two data samples. Nature of the two data samples comes out to be nearly exactly identical, and that must be identical because right from the beginning we had taken the binomial distribution for my two samples here, random dot binomial, right? Just one small difference was that this had p equals 0.52 and this had 0.48, but again it shows that that much difference is not much significant, and therefore you will say that new design is not helping much. And then last and the most important is we actually plot the difference in the click-through rate. So then you find that difference in the click-through rate is just reaching up to 0.05. Okay, compare it with that previous case, that is one sample t-test, where if you remember when you plotted that, the last one, the difference reached up to -6. So that both rectangle looks same in size, but please see the scale also. Okay, so here the scale is such that this rectangle also looks the same in size, but the scalar, this y-axis scalar is very very small. So then this 0.05 is not significant. That -6 was significant difference. So there we accepted alternative hypothesis, but here I will say that new UI has not helped much to improve the click-through rate, right? Okay, this is the interpretation of result, and this is the explanation of the visualization. Now that both is fine, I have already explained, so you can just read through it. You will follow everything. So next lecture we will talk about this thing now, paired sample tests, right? So paired sample tests are used to compare two related samples, such as measurements which are taken before and after an intervention. This is called independent sample test because here the two samples are completely independent. Okay, so that means you take two different samples. You are running your online retail platform, so you have suppose millions of customers. So to the new UI designer has come with a new design, so you will isolate one sample of maybe 10,000 customers and give him old design, and another sample of some another 10,000 customers and give him the new design, and then you will compare null hypothesis or alternative hypothesis, what is obeyed. So they are two unrelated samples. While here you will paired t-test, you will take only a single sample, but you will do some modification with your maybe one feature or something, and you will take the some mean value before that modification and some mean value after that modification. Okay, so that is same sample is there, therefore they are two related samples, right? And there you will take t-test related. Okay, so that is called paired sample t-test, right? So that will be the topic of our next lecture. See you in next lecture. Thank you.